In 9.7 we have trigonometric identities. So the trigonometric identities, so already you know the basic trigonometric identities like sine square theta plus cos square theta 1. And have you remember any other identities? Okay. So now if we know this identity na, so we can get the rest of other two identities as well. So if let assume if we need the identity which includes 10. Okay, so if we need a 10, so we know tan theta, that is equals to sine theta over cos theta. Okay, so let's divide the given equation. If we can divide by cos square theta, so sine square theta over cos square theta will be tan square theta, and cos square theta over cos square theta will be cancelled, so we can say what, 1. And in RHS 1 over cos square theta, as we know 1 over cos theta, that is equals to sec theta. So we can say that this is cos x square theta. So this is our second identity. Okay, now let's suppose, and we know again this same identity, we know the sine square theta plus cos square theta equals to 1, and we need now instead of 10 we need cot. So what we will do, we need cot. So the cot means cos theta over sin theta. Yeah, so now this time we will divide by sin square theta. So if we will divide by sin square theta, so what we will get, sin square theta over sin square theta 1 plus cos over sin, we know cot. So here we have square, so cot square theta, and as we know 1 over sin theta, that is equals to cos x theta. Yeah, so 1 over sin square theta we can say cos x square theta. This is our third identity. Okay, so now we can rearrange these three identities in a different form. Like in the previous session, we if we need the cos square theta, so what we will change in the sin square, 1 minus sin square theta. So we can say cos square theta equals to 1 minus sin square theta. Basically the identity is same, just what we did, we shift the sin square theta that side. Or if we need sin square theta, so we can say 1 minus cos square theta. Similarly we can do in this as well. If we can take tan theta that side, so we can say sec square theta minus tan square theta, that is equals to 1. Or if we can take 1 that side, then we can say tan square theta equals to sec square theta negative 1. So we can use these two as well. And then third, if we can take cot that side, so we can say cos x square theta negative cot square theta equals to 1. Or if we can take 1 that side, then we can say cot square theta equals to cos x square theta negative 1. So basic we have the three standard identities, By rearranging these three identities, we can make six more. So in 9.7, we have each and everything we have to prove. So the question first. Okay, which question you want to do? Or we can do the basic first and then we will move like the higher questions. So we will start from first. A. We have sin x over tan x, that is equals to cos x. We have to prove. We have proved that. So let's take LHS. So sin x over tan x we have. So what we know about tan? Can we write tan in terms of sine or cos? So we can say sin x over cos x, right? If we can reciprocal this part, so we can say sin x times cos x over sin x. This cos was in the numerator. Let cancel, sin cancel. So we left cos x. This is equals to RHS and it's proved. Now we will do the D question number. So what we have, cos square x negative sin square x over cos x positive sin x plus sin x, that is equals to cos of x. Now if you can see in the numerator we have one identity. Which identity we can apply here? In LHS numerator. No, the sine square x plus cos square x plus, not minus. Here we have negative. Basic algebraic identity is here, not trigonometric identity. Here we have basic algebraic identities. Yes, yes, we will write it once. One time we will write in positive and one time we will write in negative. So, which identity? A square, negative b square. So, sorry. So, cos of x negative, sine of x, cos of x plus sine of x over cos of x plus sine of x plus sine of x as it is. Now, we can cancel this positive to this. So, here we left cos of x minus sine of x, and that is plus sine of x. Minus sine plus sine will again get cancelled. So we left cos of x. Done. Okay. If you want to note it down the first one as well, so you can. And just remember these identities as well. The basic algebraic identities is like we can use everywhere. But let in F what we have, tan square x negative sine square x, and we have to prove tan square x times sine square x. So now what we will do now? In LHS, what we can do? Yeah, we, yeah, sine and tan we need. right? So sine over cos. So instead of 10, we can write sine square x over cos square x negative sine square x, right? But 10. Okay, let's make a cross multiply then. So sine square x minus sine square x times cos square x over cos square x. From here, what we can take common? No, in the numerator, from numerator, we are taking common, not cancelling. So in numerator, we can take sine square as a common. So here we left 1 and in this we left 1 minus cos square of x over cos square x. So just look the given function properly. Can we write sine? This is in denominator, right? So can we write like sine square x over cos square x and 1 minus cos square as we write in sine square x? Yeah, sine over cos is tan square and that sine square x as it is. So this is our RHS. Okay, so let's take the same question. We are taking like this, and we need, okay, if I can say cot square x negative cos square x. So cot square x times cos square x, right? Okay, so we have question 2. The A part we have cos square x negative sine square x, that is equals to 2 cos square of x negative 1, and B, same thing, I think we have cos square x minus sine square x, that is equals to 1 minus 2 sine square of x. Okay, so in the first A part, just remember one thing, in LHS we have cos as well as sine, but we need only cos. So we have to replace this sine with cos. Yeah, so in LHS what we can do, this cos square as it is negative. Remember one thing, while you are writing instead of sine square x 1 minus cos square x, right? So remember one thing, you have to make a bracket. Okay, so now when we open the bracket, so here we will get negative 1 plus cos square x. So cos square x plus cos square x is 2 cos square x minus 1 is as it is, that is equals to RHS. Now the same thing you can approach that question. Here we have to change cos square x. Here we have sin cos raised to 4x plus sine square x times cos square x, that is equals to cos square x. Why you are dividing? Why we are taking square root? We can't take square root in LHS because we have two different terms. Okay, so just I remember one thing. In LHS, look carefully. How many terms we have? No, two terms. Yes, yeah. So that is one term. Yeah. So this is entire one. So in this two term, can we take something common? So let's take cos square common. And here is your answer. If you can take cos square common, right? So we know cos square and sin square equals to 1. So here we can say cos square of x times 1. So that is equals to cos square of x. This is our RHS. Okay. So we don't have to think too much. Just think like what we can do basic. Okay. Like in the previous question we did a square minus b square. The standard identities we have. Here the same thing. If we can take something common, so let's take common. Reduce the function. Okay. Now the same approach you have to apply in question D. Can we erase this part? The same approach you have to apply in question D. So in D, here we have 2 times of 1 plus cos of x negative 1 plus cos of x the whole square, and we have to prove is equals to sine square of x. So let's try this question. The same approach you have to apply in the previous question we did. Can we take something common in LHS? Not cos x, 1 plus cos x. The entire bracket is similar. So in LHS, if we can take 1 plus cos of x common, so here what we left? 2 here negative 1 plus cos of x. So now 1 plus cos of x as it is, while here we open the bracket, so 2 negative 1 negative cos x. So now let's simplify. So 2 minus 1 is 1 minus cos of x. Again here, so what we have? A square minus b square. So 1 square is 1 and the cos square of x. 1 minus cos square of x is sine square of x. This is our RHS. 2 negative sine x plus cos x the whole square, and here we have to prove sine x negative cos x the whole square, and with this I will write f as well. Cos raised to 4x plus sine square of x equals to sine raised to 4x plus cos square of x. So let's think and let me know what we can do. Yes, yes, you have to expand LHS. So you have to apply whole square formula. So if we can expand this, then negative 2. Let's apply the whole square formula in bracket. So here we can say sine square of x plus 2 times of sine x times cos x plus cos square of x. Now here we know the sine square of x and cos square of x is 1. So we can say 2 negative in a bracket 1 plus 2 sine of x times cos of x. Now let's open the bracket. So 2 negative 1 negative 2 sine x times cos x. Okay. So now here we left 1 minus 2 sine x times cos x. So like here we wrote sine square x plus cos square x equals to 1. So vice versa we can say 1 equals to sine square x plus cos square x instead of this one. So we can say sine square x minus 2 sine of x times cos of x plus cos square of x. This one we can write in these two forms. Right. So now if we can look the entire thing while we expand this, here we have positive because here we have plus sign in between. So that's why we have 2 times of AB. Here we have negative 2 times of AB. So we can say this is sine of x negative cos of x the whole square. This is our RHS. I will give you a hint. You can write cos raised to 4x is 2 times cos square x times cos square x. Okay. After that, can we write cos square x in form of sine square of x 1 minus sine square of x and again 1 minus sine square x. Okay. Then let's apply distributive law. Means you have to just open the both brackets. Okay. Let's try. Okay. So what you did, we can say in let's just cos square x times cos square x plus sine square x. This is our LHS. So this is 1 minus sine square of x, 1 minus sine square of x, and can we say this is 1 minus cos square of x. Now let's multiply. 1 times 1. It's okay, no problem. Yeah, it's okay. You can later convert into the 1 minus cos square x. So here minus sine square x and then plus sine square x minus minus will be a plus positive sine raised to 4x and here we will plus minus cos square x, right? So this and this will be cancelled. Plus 1 that is 2. 2 plus sine raised to 4x negative cos square x. 1 minus. Yes, here the negative sine square x and negative sine square x. So here we can't cancel these two parts. So now this, let me take one negative sine square of x. This is, we can say this is cos square of x, and with this one we can write again one negative sine square of x and negative cos square of x, this, and this sine raised to 4x as it is. So this positive cos square x and this negative cos square of x will cancel. So here we can say this one negative sine square of x is cos square of x plus sine raised to 4x. So now we can rearrange the things. Question third, B part. Here we have sine of x over 1 plus cos of x plus 1 plus cos of x over sine of x, and we have to prove 2 over sine x. So just let me know what we can do and how we will approach this question in LHS. Yes, we will. We can cross multiply. So sine times sine is sine square of x, and here what we will get 1 plus cos of x the whole square, and in the denominator we can write sine of x times 1 plus cos of x. So here let's apply a plus b the whole square formula. So plus 1 square is 1 plus 2 times of cos x, and plus b square means cos square of x, and again denominator we will take similar, sine of x times 1 plus cos of x. So can we make this sine square of x plus cos square of x is 1? So we can say 1 plus 1 plus 2 cos of x over sine x 1 plus cos of x. So let's make one more step. 1 plus 1 is 2 plus 2 cos of x over sine x 1 plus cos of x. Right? Can we take 2 common? So 1 plus cos of x over sine 1 plus cos of x. So we can cancel. So we left 2 over sine of x. This is our RHS. So we have cos raised to 4x negative sine raised to 4x over cos raised to 2 of x, cos square of x. That is, first we have to prove 1 negative tan square of x. Now, what we can do in this question? In the numerator, we will again apply the a square negative b square. So, in LHS, can we write cos raised to 4 instead of cos square of x square and negative sine square of x the whole over cos square of x. So, here we can use a square minus b square. So, instead of a, we have cos square of x minus sine square of x 1, and again cos square of x plus sin square of x over cos square of x, right? Now we know this part is 1 because we need 10. Yeah, so let's keep it as it is. So we can say cos square of x negative sin square of x over cos square of x, and this times 1, right? So now we will separate the denominator with the numerator. So 1 times this is the similar cos square of x minus sin square of x. So can we separate the denominator with the numerator like this? We just separate. Now cos will cancel. 1 negative sin over cos is this is our RHS. Next we will try the last as well. In D, what we have sin square of x 1 minus cos square of x over cos square of x 1 minus sin square of x equals to 10 raised to 4x. Oh, yeah, that's why I'm laughing. You can write sin square x. This is sin square x, this is cos. So in LHS, the basic thing sin square x times sin square x over cos square x times cos square x. So sin raised to 4x over cos raised to 4x, and sin over cos is 10. 10, right? So let's take a note.